So we start from the trigonometric functions, right?
Yeah.
So if you look at the book, at one Sadler's book, and in the trigonometric function, there is first, which is sinusoidal function. You have an idea of the sinusoids?
Pardon?
Do you have an idea of the sinusoids? What is a sinusoidal function?
No.
Okay. Uh, the sinusoidal function or sine, if I plot it, it is something like here, right?
Yeah.
So the maximum value is 1 and the minimum value is -1, right?
Yeah.
And at 90 it has a value of 1. At 180 degrees, so it is like this. 180 degrees it has a value of 0. At 270 it has a value of 270 -1. And at 360 has a value of 0. Do you have this idea or no?
Yeah. I have. Yeah.
Okay, it's like a swing, if I should say.
Yeah.
Like a swing. If you take a swing, I take another color, and so a kid is, or a pendulum maybe. So if you see, let's say it goes higher, yeah,
Yeah.
it goes like this, maximum here. So if we think this is 0, so if you see, it is also falling something like this. It goes up in one side, go to the maximum position,
Yeah.
then start coming back, come to 0, then go to the other side. Yeah.
Yeah.
If we,
Yeah.
for example, take this side in this, so this side corresponds to this. Does this make sense to you?
Yeah. This makes sense.
Okay, good. So this is a this is y is equal to sine x graph. Have you looked at it earlier also? Yeah.
But
Have you looked sine graph earlier also in your
yeah.
what is 360 equal to in radians?
Is this a unit circle?
Yeah. So
Oh
what?
no, I'm pretty weak on this.
Okay. Actually, if you see, we have a we say 180 degrees is equal to pi radians is equal to pi radians. It's a conversion, right?
Yep.
So how much is of total circle here? Or if I just show it to you, so it is coming from 0 degrees here. So actually on the x-axis we have the angle, right?
Yep.
So it means it is x because it could be theta. So let me ask you, what is the value of x here at this point?
90 degrees.
90 degrees. Very nice. And here where I'm putting my blue dot.
180.
Good. So if I want to convert them in radians, we know the, and this is the relation, 180 degrees is equal to pi radian. So I can, if we, it's like changing the scale. So in the high school or in the earlier schools, you have been taught 3 degrees, and perhaps in year 11 you start learning something else, which is radiant. It's like this. For example, in temperature, you know what are different type of the temperature scales?
Yep.
What?
Like Celsius, degree,
and and Fahrenheit.
Fahrenheit.
So it's,
Yep.
you can consider this also, that
Yep.
there is a degrees, and then there is another scale which is radians. So 180 degrees is equal to pi radian. So I have written in place of 180 degrees beneath it pi. What would be 90, you think?
Half pi.
Yeah, pi divided by 2. Very nice. What would be 270?
3/4 pi.
Yeah, 3 pi over 2.
And then 2 pi would be 360.
Yeah, that's good. Yeah. And
Yep.
our sinusoidal function actually repeats itself, because as we know, if we make a unit circle and we say this is 0, so this comes back to the 360, and then it's repeating itself. Does it make sense to you?
Yeah.
So let me take a red color, and because, so it means our, this is again going like this, and here also it is going like this. Yeah.
Yeah.
Does it make sense to you?
Yep.
Okay, this is something very interesting then. Yeah, let me ask you, if I put like this, this was 2 pi. What would be this value in radians? This is 1 again. So how much it has added? After 2 pi, how much it has traveled on the x-axis, you think?
What do you mean?
Can you can you say what is the angle here?
I'm not sure.
Ah, it says we are repeating itself. So if it is 0, it has gone up here. And after how much time it goes to 1? Again, let me see. Let
90
me
degrees,
90 degrees. So this angle would be 360 plus 90. That is equal to what?
450.
450. So this is 450 degrees. And if you convert them into radians, because at the moment we are talking, can you tell me what is 450 in radians?
Would it be 2 pi over 2?
Hmm? So 2 pi over 2 would be just pi because you would cancel 2 pi. How much is this difference in radians? How much we have traveled in here? So the line which I put here, this
Uh,
one. How much is this difference in radians? You know in degrees. How much is this difference in degrees?
pi over 2?
Yeah, pi over 2. So it means you will have to add pi over 2 to 2 pi. So this is actually 450 is 2 pi plus pi over 2. Do you know this? Do you understand
Oh,
the
okay,
concept?
yeah.
Yeah?
So, yeah, you add it.
Yeah. So can you tell me what is this in fraction?
What's what in fractions?
Yeah, so it is 2 pi plus pi over 2. Can we get
Yeah.
just one value for this? Because it's like,
I don't understand.
this is a value. Like you said, you could have written this 450 as 360 plus 90.
Yeah.
So this is the same thing which we are doing. 2 pi is for 360, pi by 2 is for 90. So can we write this as one thing because it's addition? Can we add 2 pi plus pi over 2? What would be the answer?
Mm, 2, 3 pi over 2?
No, not 3 pi over 2. The fraction says if you have to add fractions, you would make their denominator same. You remember? So what is
Yeah.
here? 1. So you have to make them equal, the both fractions denominator. So you would multiply here
Yeah.
by 2 and here also by 2. So it will become 4 pi
O
upon
over 2.
2 over 2 and pi over 2. Now they have the same denominator, so it becomes 5 pi over 2. Does it
Okay.
make sense to you or no?
Yeah, yeah, yeah.
So this is actually 5 pi over 2 or
Okay.
450 as you said.
Yeah.
I think I'm making a little mistake or no, I'm not making a mistake. Okay, good. Does it make sense to you?
Yep.
If we look at this, the value of, so if you see sine x, we would make let me make a relation now. If you look at this, which we have just done, so can I write this thing as sine x plus 2 pi? Yeah.
Yeah.
Why? Because here x was 90 and then we added 2 pi and we,
360.
yeah,
Yeah.
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 And what is this equal to? The value is whatsoever the value. So this is actually sine x plus 2 pi in our case for x equal to 90. And this is equal to what? Sine x. Does it make sense to you or no?
No.
No?
No.
Okay, let me try to explain it once more. What was the value of sine pi over 2 here?
Uh, 90?
No, no, sine and x is 90, which is on the x-axis. What is the value on y-axis? Because that's the
1.
value, 1. So sine 90 is,
1.
what about sine 450?
Would be 1 as well.
Yeah. So how much is, and if you see anywhere, here it is where I am putting my mouse. It is theta is 0. What is the value of sine 0?
0?
Yeah, good. And if we add 360, what is the value of 360 then?
0.
Sine 360 is 0. Again, if we add 360 in this, what would be the value? So 360 plus 360 becomes 720 actually. So what
0.
would be the sine 720?
0.
Very nice, 0. So it means now we come to this relation. It says whatsoever is theta, for example, in this case 0 or 90, if you add 2 pi into it, the value is the same as it was
Oh,
of
okay,
sine.
yep.
Does it make sense to you now?
Yeah,
This is an important relation. Get it?
yep.
Okay. So it means, and then there is something which we also say cycle. Cycle means where uh, the values start repeating it. Can you tell me what is the cycle of sine x?
Mm,
After what values of x start repeating?
after 360?
360, very nice. Or 2 pi radians.
Yep.
It's the same thing. So the cycle, and what is the maximum value of sine x?
1,
And what is the minimum value of sine x?
-1.
1, -1. Very nice. So it means we have done 3, 4 rules. So first was this, yeah, which I have just written. Then we say cycle, sine x cycles at 360 degrees or 2 pi radians, right? 2
Yep.
pi radians. You got that?
Yep.
And then the third thing. So this is the second thing. Let me write like this. Then the third thing which we just discussed. We said sine x values, sine x, it is either less than equal to 1 or greater than equal to -1. So this is the range.
Yep.
Yeah?
Yeah.
Do you know the concept of domain and range?
Yeah.
So what is the domain?
Mm, So the range would be between them two.
Now, so range is from -1 to 1, and what is the domain? Domain is from, the domain is of the input. So input is actually from 0 to 360.
Yeah.
You got that or
Okay. So
no?
the domain would be on the x.
Yeah, this is like this. The domain is what is in the input. So this was a chapter which you covered earlier. Domain and range.
Yeah, okay.
So you are changing theta from 0 or x from 0 to 360, and the values would be in between -1 to 1.
Yeah,
Got
okay.
that? So if we now go back to our graph, so this is 1. So this is the amplitude. It goes up 1, goes down -1. Okay. Uh, what is a vertical line test? Do you know? For a
Yeah.
function. Is it a
To
function
see.
or not a function?
Hmm?
Is sin x a function or not a function?
It would be a function
Why?
because
Proof.
because at one point it's only crossing once.
No,
Like,
the vertical line test says you draw a vertical line, right?
yeah.
And if it cuts the graph only once, it means it's a function. So anywhere
Yeah.
we put a line, which, for example, let's say we put anywhere, it will cut your graph only once. So it
Once.
is a function. This is called vertical line test. Do you know this?
Yeah, yeah.
For example, let me ask you another thing just for my understanding. If you have a function something like this or a graph something like this, is it a function?
No,
Why?
because it crosses the line more than once.
No, if you put a vertical line, say this thing, if you put a vertical line on this,
Yeah, it
it,
cuts through.
yeah. So for example, so this is called vertical line test.
Yeah.
Vertical line test. You get that?
Yeah, I got this.
Okay, so is sin x a function or no?
It would be a function.
Very nice, very nice. So let me somewhat. Now we see another very interesting thing. So we have those 2, 3 things. Now we would see another interesting thing. Uh, where is our zero? You know, Where is our 0 in this graph? I hope I haven't cluttered it a lot. So our 0 is here, right?
Yep.
Okay. And if you look at here, what is the angle at here? Can you tell me? Do you have an idea? Where it is -1, what would be x here?
-90.
Very nice. It's -90. Oh, this
No,
gives
would it
us,
be -180?
this is -180,
Yeah, yeah,
and this is -270. Yeah?
yeah,
Or this shows us a very interesting thing. So now I move to, should I write it down? Let me just zoom. Let the fourth thing, fourth rule of sin x, right?
yeah.
So sin minus x. Let me write it and then we would understand. Minus sin x. Does this make some sense to you, or is it?
Yeah, yeah,
For example, we said sin 90. Example. So let me take other color so that. So example of this thing. Example. If we take sin 90, the rule says it would be equal to. Can you help me, please?
negative sine 90.
Yeah. So what is sin 90?
Oh, 0.
Look at
No,
look at the.
-1.
Is it sin 90 -1?
Oh, +1.
And +1 times my negative becomes.
Negative.
So this is -1. And what is sin 90, which you have seen here, where I am putting my pen? It is also -1.
Yeah, okay.
Does it make sense? This is for all values of x.
Yeah, okay.
So we have at the moment done. So this was first. Sorry, here. Yeah. So we
Yeah,
are doing some rules. Does it make sense to you?
yeah,
This is something very interesting. Uh, it is called. Let me see. It's if I generalize this thing, it says f minus x, the value of a function at minus x is as negative times value of that function in positive x. Does this thing make some sense to you or no? I'm generalizing it. Instead of sine, we say any function.
yeah, yeah, it makes sense.
Yeah.
Yeah,
I make another example of such functions. Let's say if I say function is instead of this something like this. Do you see this is also the same?
yeah,
For example, here the value is positive and here the value, if you move
negative.
so much there, here, the values are actually the same, but just positive, negative. So this function, such type of functions are called, have you heard, do you know this or no?
No.
Have, they are called odd functions.
Okay.
They are called odd functions. If there is a function something like this, which is on negative and positive same, what would this be called? Just make a guess.
Even?
Very nice, very nice. Good, good. They are even functions. Yeah?
Yep.
Does it make sense? So actually we say sin x is an example of a odd functions.
Yeah,
Okay. So we understand that. Yeah?
yeah.
We okay. Let's come back to here. So any question till now?
Nope.
So now we try to make so I have been covering it with the degrees, but it is same with the radians, right?
Yep.
And what is the conversion? The conversion is this 180 degrees is equal to pi radians. All good?
Yep.
Okay. Uh, so now we would take what is another function. So this was we did this for sin x, right?
Yeah.
Now we would do other trigonometric function. Do you know of some other trigonometric function?
Cos x.
Very nice, very nice. So y is equal to cos x. Let me, instead of red, change it to green so that it makes a little difference what we have been doing. So now we should learn about cos x. So the sin x was something graph. Do you know the graph of cos x? Have
No,
you come across it or no? Like
no.
like we did for sin x? It, it doesn't matter. I would draw it and then we would. Yeah.
Yep.
So if I draw a graph of a cos x, this is positive one, this is negative one. So it goes like here. I'm sorry if it goes like this, and it's also repeating.
Yep.
So this is positive one, and so this is pi over 2. Pi over 2 means,
90 degrees.
and this is pi. This is 3 pi over 2, and again this is 1. Yeah, it's not very
Yeah.
eloquently or very nicely drawn, but I hope it makes sense.
Yeah. Yeah.
So we would again look at those type of four things. Four properties which we did for the sin x, we would do them. What is the cycle of this cos x?
360.
360, or in radians?
2 pi.
Very nice. So it has and it's also repeating. So if I draw, it would come like this. Yeah.
Yep.
What would be this value? Here, x value.
Negative pi over 2.
Very nice. Negative pi over 2. And what would be the value here?
Negative pi.
Very nice. So first of all, let me ask you the things which we did last in the sin x. Is it an even function or an odd function?
Odd.
Odd. Look
Yeah.
at look at this. What we have been. So I just odd function then. Is cos a odd function or a?
It would be odd function.
Hmm? Why?
Odd function?
If you see,
Because,
the odd function says what is the value at here, fx something, f minus x, the same. You see here, odd function, the values should go.
or it should intersect the 0.
No, 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 no. Again, what is the definition of this? Was the definition of odd function. It says f minus x is equal to minus fx. Yeah.
Yeah.
If I put here, for example, the value, let's say this is pi over 4, because this is half of it, right?
Yeah.
And here it would be, so minus pi over 2 is this, right? This
Yeah.
is pi over 4. So what is, this is 4. Let me write it a little more clearly. What is the value of cos pi over 4? It would be this value, whatsoever that is. We do not know at the moment, right?
Yeah.
What minus pi over 4? The value is same or different?
The same.
The same. So it means f minus x is equal to fx.
Fx.
And for odd function, it was f minus x is equal to the one which
Fx.
just look at above.
Yeah.
What was for odd function?
Negative fx.
And here it f minus. So is it odd function then?
No, it would be even.
Yeah, it's a even function. So cos x is a even function. Does it make some sense to you?
Yeah. Yeah.
Okay. So sine is a odd function, while because, for example, what is cos pi?
Cos pi would be cos 180.
Yeah, what is that from this graph?
0.
Is it 0 here? Where is the graph? Where is the value of this is pi? What is
Oh, it
cos
would
pi?
be negative 1.
Yeah, cos x. Yeah, negative 1, because here it is. What is the value of cos minus pi here?
Negative 1.
It's the same. Yeah, so it's an
Yeah.
even function.
Yeah.
So, so okay. So one thing which we have found is it is an even function. What is the period of cos x? So let me ask first thing. What is the period? Period means after which it repeats, or the cycle. Period of cos x is
2 pi.
Yeah, it's the same as sine x.
Yeah.
There is 2 pi. Number 2. Yeah, it means it repeats itself in 360s or 2 pi radians. Second thing, what is the maximum and minimum value?
+1 and -1.
So it's the same thing. It's the
Yep.
same as the sine has.
Yeah.
Does it make sense to you?
Yep.
Uh, okay. Now, let me ask you this thing. The relation between cos minus x and cos x. What is the relation? So I want to put some sign in between them. What should be there?
Pardon?
What is the relation between cos minus x and cos x? I want to put a sign here in between them, which I haven't deliberately put.
Oh, that would be equal.
That would be equal because they are even function,
Yeah.
like from here. So even function. Does it make sense to you?
Yep.
Okay, very nice. So they are even function. So one interesting thing, if if a function is an even function, you take its reflection along the y-axis, it's the same. Do you see this? This is the
Yep.
y-axis, yeah?
Yeah.
If you take a reflection, it's the same thing. While
Yeah.
in case of odd function, which is high, like this, is the
Yeah.
reflection the same?
No.
No. Then you have to multiply it with a negative number.
Yeah.
-1, I mean. Does it make sense?
Yeah.
Good. Okay. Something very interesting now. Let me see. Uh, we haven't drawn these two uh, graphs on one scale because I was just making it. But if you see, somehow you think this red one is y is equal to sine x. We know that, yeah? This was
Yeah.
sine x. Let's say you push this graph 90 degrees towards left. What is meant by pushing it? I mean this point, which is pi over 2, we push the whole graph towards left.
Yeah.
So what this graph will become then?
Oh, cos x.
Very nice, very nice. So, so normally what we see, or let's say the other thing we see here, this is cos x. Uh, if we push this graph 90 degrees towards right, what would happen to this graph?
Sin x.
Yeah, sin x.
Yep.
It will become sin x. So that brings us to another relation which we see. Normally, if you push right side, we say you are pushing it. So let me say, we said if cos x is pushed 90 degrees towards right. So once we push towards right, we put a negative sign.
Yeah.
And so this would become what? This is actually equal to
Sin x. Sin
sin
x.
x.
Yep.
So this is one relation, very nice. And then we said if it is a sin x, we move it towards how much?
Left side.
Left side. And if negative is, so if we are putting negative sign to demonstrate or to say that it is moving towards right, we
Then you
would
would
put
add.
positive. Yeah.
Yep.
So it means cos x is equal to sine x plus pi over 2. Does this relation make
Yeah.
sense to you?
Yeah. Yeah.
So that's quite an interesting thing. Okay, so now we move to, after sin x, we move to now y graph for y is equal to tan x, right? Let me see if I put this, I make it a little more. So we are saying y is equal to tan x. All good?
Yep.
Okay. Now the question is, um, what is the relation between sin x, cos x, and tan x? Do you know that?
No.
Hmm?
No.
Tan x is actually sin x divided by cos x.
Cos x. Oh yeah.
You know that
Yeah.
relations. Yeah. Okay. Um, I would, instead of referring it, I try to make the graphs some small graphs of sine x and cos x. I say this is +1, this is -1. So I make like this. This is sine x, yeah? Y is equal to sine x. And we know this is pi over 2. I remain in radians. This is
Yeah.
pi. This is 3 pi over 2. Yeah.
Yeah.
And this is 2 pi. I should make a little smaller so that let me just rub it so that it doesn't confuse you. Okay. So this was pi. This was 3 pi over 2. Yeah. 3 pi over 2. It's a little confusing, so just I don't want that. It's so this point is 2 pi and this is 3 pi over 2. Is it clear to you?
Yeah.
Okay, let's make a cos x then. And now I draw a cos x. Again, something like this, and it's somehow, yeah, okay. So we try to make a, again for this value, I say this big is pi, this is 2 pi, this is, I'm trying to plot on the same
Yeah.
references, right? So cos 0 was 1, yeah, so I put
Yeah.
this is 1, and this is, and it was at pi over 2, it was
0.
0. Oh, I'm somehow, it should work. There is some whiteboard is a little bit giving problems. So I just, okay. So we had this, yeah, at pi over 2 it is 0, at pi it is negative
Negative
1.
1.
So this was, then it was 0 and like this, right?
Yeah.
So this is y is equal to cos x. And we try to make a graph on the basis of this, and I take now blues so that we have a different colors for all these graphs. So I try to make a blue. So what would be the value which you think? Let's first of all try to make the things where it is sine over. So this is, so what would be the value? So this I'm trying to, so this is x and everywhere it's x, right?
Yeah.
And we are now trying to y is equal to plot tan x. What would be the value of tan x at 0 degrees or 0 degree radians, you think?
Uh, no, I'm not sure.
It's the relation is given here on the left hand side. Tan x is sine x over cos x. What is the value of sine 0? Because we are,
Sine,
sine 0
sine
is
0.
0. And what is the value of cos 0?
1
So you divide 0 by 1, what is the answer?
is 0.
Yeah, so it means this is the value of tan x. At x is equal to 0, the value is 0. Does it make sense to you?
Uh, so I just get sin x and then get cos x and divide
Yeah,
it.
yeah, yeah, yeah. You see the relation says sine x and cos x. So
Yeah.
whatsoever is x for tan x, the same x should be calculated in sine function, and same at cos function. You divide, that would give you.
Yep.
Does it make sense to you?
Yeah.
Okay. For example, what is at pi over 2? So what at pi over 2? What is sine x?
-1.
Ah, at pi over 2. Look at the graph.
Pi over 2 or 1.
1. And what is cos pi over 2?
cos pi over 2 would be 0.
Oh, 1 divided by 0?
1.
No.
0.
Any number
Yeah,
divided by
yeah,
0 is?
0.
No. Undetermined.
So infinite?
Yeah, infinity or not defined. So, so if I put this thing like this, I bring this. So at this point, these are both are. So if I see this graph should go something like this. Do you see? Because at pi over 2, this becomes infinite.
Oh, it just keeps going.
Yeah, it's undefined
Yeah,
or
yeah.
infinite. And similarly, if you have a minus 90, which is here, minus pi over 2, so it goes like this. Do you see this?
Mm,
We didn't drew on the negative side. We can
yeah,
draw
yeah.
it and then you would know. For example, if I see this is sine x and I take the same color because otherwise. So what was sine 9 minus 90? You remember?
Pardon?
Sine minus 90. It was minus 1.
Yeah, yeah.
So it is here. And what was the cos min cos minus 90?
Would still be minus 90?
Cos minus 90. What is the value?
90.
N- No, the range of the value is from minus 1 to 1. It can't be 90.
Wait, I
You
don't understand.
why we said this is the range. You remember? Cos
Yeah, from
cannot be
negative 1
90.
to.
The value can't be 90. It is between minus 1 and 1. So what is cos 90? Cos minus 90. Because this was the graph which we made. Let me just zoom into it a little bit. And so that you, what is cos 90? So this is the graph which you are seeing now. What is cos minus 90?
0.
Yeah, 0. Yeah.
Oh, yeah.
Yeah. So you maybe you can also open your book so that you are clear what is there, right?
Yeah.
The graphs. So we are trying to graph it. So at pi over 2 minus pi over 2 rather, the so red color, is it a red color? Yeah. So we had this 0. Yeah. I'm pardon me for not being that clear
Yeah.
with these graphs, but if so again sine is minus 1 divided by 0. Minus 1 divided by 0 is,
Would be infinite.
but now you have a negative sign, therefore it goes towards this side.
Yeah, downwards.
Does it make sense to you?
Yeah.
Okay, so I just draw more so that you are, so minus, and again this was 0, right? And at pi, so if we draw at pi, it would be again 0. Why again 0? Because at pi, look at this pi, at the pi, which is pi, sine is 0 and cos is negative 1. Yeah?
Yeah.
And 0 divided by negative 1 is
0.
0. We get that. Yeah?
Yeah.
Just so if I draw, I had drawn it a little wrong. So I just take a value because this is pi. This is pi. So at pi it is, and it would go here, it is 3 pi over 2. Yeah. So it would go something like this at infinity. 3 pi over 2. Why? Because at 3 pi over 2 cos is 0. So every point where cos is 0 would cause infinity. And on the other side, it would go towards negative. Yeah.
Okay. Yeah.
So you have a discontinuity at this points, which is pi over 2 or yeah. So at pi over 2 and minus pi over 2. But so let me ask you a few things. What is the cycle of this graph of the 10x? So these all those points which we have, it repeats after how much degrees?
Would it be the same?
How much?
360?
Is it? You see what is the
Uh,
difference between these and these? How much is this? This is pi over 2, this is minus pi over 2. So how much is this? Difference of these two.
Between negative pi over 2 and pi over 2.
So what is the total width?
Oh, wait, 180.
180 or pi.
Yeah,
And then again, this is pi.
pi.
So it means
Okay.
what is the cycle or how much is it's repeating itself?
Cycle would be 180 or
180.
pi.
Yeah, it's a pi radians.
Yep,
While for sin x and cos x it was 360, but
yep,
for this, yeah. So we write some again. First thing, tan x period is pi. Does it make sense?
yeah.
Not 2 pi.
So it will repeat after every 180 degrees.
Yeah, you have seen the graph.
Yep, yeah.
So we in math we look at the things, and it's in English you can imagine, you can, but in the math the things are as per the graphs and the other thing. So the period of the graph is pi radian. If it is pi radian, you remember we had, for example, let's go back to this, and then we have seen here, if it was pi, we said, where is it? Oh, no, I have to find it here. Yeah, it was here. Here. So here we had written sine x. What was the period of pi? It repeats after how much?
2 pi.
So, and there we put this thing, sine x plus 2 pi is sine
Tan
x.
x with 2 pi.
Why?
Yeah.
In case of tan x, what is the cycle or the period?
Uh, pi.
Pi. So it would be tan x plus pi is equal to what?
Tan x.
Yeah, very nice, very nice. So that's something which, so it would be, just let me zoom out somewhat and we come back to this. Yeah, sorry, it's somewhat is taking, as I said, sometimes it is not behaving well, but no worries. So we saw what we saw, tan x plus pi is equal to what?
Tan x.
Yeah. And even this is for minus pi also. If you move toward the left, even that is zero.
Yeah,
If you see this value, if you move, this is pi, yeah? So you
yeah,
move pi, so it's plus minus. Does it
yeah.
make
Okay.
sense?
Yeah,
Okay. And what about its maximum and minimum values?
would be infinite
Yeah, so it means
and
it's
negative
not like
infinite.
minus one and this, right?
Yeah.
One more thing now, which, and then we finish today's lecture.
Yep.
It is tan. What is the relation tan minus x is equal to what? Is it an even function or an odd function? Let me know first.
It would be an odd.
Odd. Very nice. So in the odd function, tan minus x would become equal to minus tan x, minus times tan x.
Okay.
Does it make sense to you? It's a odd function.
Yep.
Okay, that's very nice. That's very nice. Okay, I'm sorry, just one thing which we had here, you would put, oh, I had put plus, so it's also sine x plus 2 pi, and here also minus. So it's the same thing as we did
Okay.
for tan, and similarly, it is for the cos.
Yeah. And
Yeah,
the positive and negative is if you want to make it like left or right.
yeah,
Yeah. Okay.
yeah, left and right. So
Yep.
negative means you move towards right,
And
and
positive means left.
yeah,
Yep.
positive means left. Okay, so I think we are done for now.